We've looked at how gates are set up into multi-levels. And when we look at some multi-level gates, our last example, we can say, okay, maybe I have an SOP orientation. I have a couple of AND gates that are feeding in an OR gate. An item that may come up is we likely want to know how long does it take to solve our result. Well, how long it's going to take for our result to be found has to go that we have to follow a pathway through. So if I pick an input, I follow that input and I see what path it would need to follow through. Now, every gate we end up having is made up of some resources. Usually we say these are transistors that are creating this AND gate. Well, it takes time for the gate to switch. The switch can be I go from a 0 to a 1 or a 1 to a 0. It takes some finite amount of time in order to get that item to be accomplished. So let's just say, for example, we say that's 10 nanoseconds. And let's say it's the same for an OR gate. That for an OR gate, it is 10 nanoseconds. Well, we might end up saying, what is the timing of this? The timing is 10 nanoseconds with 10 nanoseconds. So we can add up the total path time, and the total path time ends up being 20 nanoseconds, which gives us some timing for how long it's going to take for our circuit to be produced. Now, we might have differences for every gate, and NOT gate doesn't really have to do as much items as just switching the value. That might be, 5 nanoseconds. Maybe we can say we have an AND gate that has 2 inputs, so 2 input AND gate. Okay, maybe that's 10 nanoseconds. Maybe when we move to like a 3 input gate, because I have more electricity signals, a bigger truth table, maybe the time becomes a little bit larger. Maybe that's 15 nanoseconds. So it can really have that we need to look at an entire path. But as we talked about multi-level circuits, maybe we went from an AND to an OR back to an AND gate setup here. This is 3 levels. We have a level 1 at the bottom piece. We have a level 2 and a level 3. And let's have some inputs. Let's have A, B, C, D as inputs. And let's have E be an input. Now, at any point in time, so at any point in time, one input may change. It doesn't have to necessarily be I get all new values for A, B, C, D, E. I could get one new value. Well, each thing will have a different path. Let's say here, for example, all gates are 10 nanoseconds. Okay, so I got a 10 nanoseconds for A, 10 nanoseconds for this OR, 10 nanoseconds for this AND gate here. Well, if I take a path of A and I follow A through, the time for path A is I go 10 plus 10 plus 10. I end up at 30 nanoseconds. But if I follow the path of E, that's even smaller. That's only 10 nanoseconds. So it's a little bit faster to find the result if I see that only E is changing. For every bit that changes, we have to go through this entire path. Well, a lot of times what we are concerned about is for timing purposes, a lot of times we rely on the longest path. Or in other terms, we call this the worst case. And for us in this example, that ends up being, 30 nanoseconds. The path E is the fastest. Path E gets us to 10, but if we needed to know how long to wait for a potential answer when we do not know which of the 5 inputs is changing, we have to wait at least that 30 nanoseconds. So that gives us a little bit about timing when we look at